Okay, so yes, so today we'll be learning about high-level design. Okay, right from the scratch we'll start learning, and over the next few weeks we are going to master the concepts of high-level design. So the first thing, whenever you see any system out there, okay, so basically any system out there, it generally consists of these things. Okay, so if you see, for example, you take an Amazon website or any Flipkart or any e-commerce or any kind of scalable system, if you see, that's generally decomposed into these in these components. You can hear me properly, right, Varun?
Yes, I can hear you.
Okay, okay. So basically, the system is divided into these components. So this is a client over here. Okay, and then after, so basically, this is a client. We are generally the client. So what we do over first is we hit the URL, for example, Amazon.com, right? So what happens behind the scene is this goes and then first hits the DNS server. Do you know what is DNS? And then it gives us the IP address of that. So DNS is basically what it does is
Right.
its main purpose is to transform this host name into the IP address. Okay, so first it hits then it gives the IP address of the server. Okay, then what happens is with that IP address of the server. So what is this IP address? This IP address is a public endpoint. Okay, remember these terms. This is a public endpoint which is exposed to throughout the internet. Okay, this is a public endpoint of what now? So now this public endpoint is generally of the, for example, there is a layer of any organization out there. So this is, for example, you can consider as a layer, and inside this layer, this is where the company server sits beneath. Okay, and this is the outside external world. Okay, so now this layer,
Okay.
so now this layer exposes us this IP address. This is a public endpoint, anybody can hit it. Now inside this after this layer there is another inside this layer, the first gateway is known as API gateway of any company. If you see, there is a system server called API gateway that sits over here, okay, of any organization. This is the first level of
Okay.
entry to any company, if you see. Okay, now this API gateway, so basically the IP address that is exposed to us is the API gateway. Now this API gateway serves us various purpose. Okay, what are the purpose of API gateway? So if you see, what is the purpose? It acts as a gateway to any organization, right?
Right.
Okay, gateway to any organization or any system out there, right? Then what other features does it provide? It acts as it gives us the security for the entire organization, right? You can secure because you are not making your system vulnerable to outside system. Uh, of your critical servers, right? Only your API gateway IP address is exposed. So security is also taken care. Then over here itself, there can be and after this we'll discuss more on more functionality of API gateways. So just remember, there's one layer at front of it that is present at the API layer, API at the first level of any organization. Okay, there are more functions of API
Okay.
gateway. We'll come to that, but first level is this one. So now what happens is, so for example, you make an Amazon.com website. You see a very beautiful home page, right? Over here,
Hmm.
home page, and then the navigate all these bars, your order section, and your this one, right? Your all this nav bar and breadcrumb and everything, right? So you can consider this as a different microservice altogether. For example, let me draw nicely and show you. For example, over here, there is an order section over here. There is a profile section over here. There is a banner written festive session going on, all these details. Then there is a breadcrumb mobile and all these products basically, right?
Hmm.
So all this, and then you have a nav bar over there, contact us and all that. So you can consider each and every component as a different microservice altogether. So this is basically your order service. This is basically your profile service. This is basically your product service. So that means they entirely are a different component inside an organization. This is a different team. This is a different team. This is a different team. Contact us would be a different team, kind of a kind of point of contact team. Then this would be some other team. So this is how an organization's microservice components work. So you see from the outside world a single monolith application, but inside an application there are various microservices that works together. Do you have any questions till now? In between, if you have any questions, you can ask. Okay.
Yeah.
Is it fine or anything?
No
Okay.
questions till
Okay.
now.
Okay. Got it. Okay. So these are the different microservices that are present inside any application. If you see out there, for us it looks as a monolithic service, but inside it is a microservice altogether. So now you can see, right? So for example, you have profile service, you have personalization service, you have notification service. So these are different microservice altogether. They will have its entirely different database, they will have its entirely different server, they will have its entirely different team. Same goes for this, same goes for this,
Mm-hmm.
right? So now these teams, how do they communicate with each other via API, their API that they expose? So profile team will
Mm-hmm.
expose us API. For example, profile team will expose us API like slash profiles slash user ID or something. Notification team will provide us API like notification slash user something. Personalization service will provide us. So if you see, there are hell lot of APIs that is exposed if we combine all of these together, right? There will be a lot of
Mm-hmm.
APIs that will be exposed to us. So now the responsibilities of each team lies with their API also. For example, all the APIs concerned related to profiles will be taken care by profile. All the responsibilities of profiles API, personalization API will be taken care by personalization. Same goes with notification server. Okay. So now the
Mm-hmm.
question arises, how as a client, we as a client hits these APIs basically. So for that, what API server does is, so so for example, just a minute. So
So
yeah, you have
API
any question?
gateway is for our, yeah. So API gateway is for public facing APIs, right? The
Correct,
public
public
facing
facing APIs, right?
APIs.
So
Okay.
these
And the
profiles, right?
microservices that we have,
Mm-hmm. Yeah, yeah, go
the
ahead.
microservices, they
Mm-hmm.
interact internally
Right,
using non-public APIs, private APIs, correct?
right. That is also there, but these microservices API, right? They are also public. How are they public? I will tell
Okay.
you. So, so for example, you will also be seeing that whenever you go inside any page of Amazon, you will see like products slash a large
Mm-hmm.
hash value something. Okay, that's
Mm-hmm.
the API that is being exposed by product. But you are not directly calling to profiles API, right? You are only calling Amazon's
Right.
website. They are internally redirecting everywhere. So who is doing that
Okay.
internal redirection? That is being served by API gateway. So you see, internal routing is done by
Okay.
API gateway. Very, very important terminology. Internal routing or API routing.
Mm-hmm.
Routing of API, that's the correct term. Okay. So it's routing. So
Okay.
routing of what? Okay, so now let us see. So now API gateway, what it does is it internally has servers inside this one. It will check. So it internally has this one. You can think of it like a router who will route that slash profiles API, go to profiles microservice, slash notification API, go to notifications microservice. So this is a microservice 2, microservice 3.
Mm-hmm.
So this is routing also. That your concern, take a look at it. Your concern, take a look at it. So
Mm-hmm.
this is what concern separation of concern is being made by API gateway. So very important question. The role of API
Mm-hmm.
gateway is routing also. So they are doing all this routing. Okay, security routing. So now after doing this routing, what? Yeah. So API gateway, and then they also do caching as well. Caching of data, most frequently used data. For example, if you see your Amazon.com website, you will see an immediately image being popped up. Those are generally served
Mm-hmm.
via CDNs. We'll cover CDNs later, but right now you can think of as a caching layer, which is even present before API gateway, and these are all third parties servers, which only serves
Mm-hmm.
for static data kind of thing. We'll cover CDNs more whenever we discuss about caches there. So API gateway role
Mm-hmm.
is this one. Routing was the major this one, and there are various popular API gateways there. You might have heard about Eureka servers, or I think
Yeah, yeah.
routing within AWS. I'm not sure. S53 or Route 53 something in
Yeah,
AWS
Route
something.
53.
Yeah, something sort of. So AWS provides all these things. Okay, by default. Okay, so
Mm.
now so that covers about the API gateway. So now, for example, so how do API gateway decides which APIs to route upon? That is something that's something business business logic, business decides how do they route, but most of the time how do they route is on the basis of API version or the service version or something. For example, uh, it will be having something like 2020 1234. 1234 is the products service. So you will see something like 20201345 slash products slash something slash user slash something, either on the regex on this users or product or on the basis of these. So they make a segregation that this should be routed to this service, this should be routed to this service. So that's how internally they route it, okay, onto their services, and then then they then the API, the normal request response model works. So this is how API gateway routes the request. So now once API gateway routes the request, any questions do pitch in between. Okay. So now
Mm-hmm.
API gateway, what it does is it routes to a particular service. For example, over here it routes to the there is an API of orders slash user ID one. Okay. Or order one or order number, whatever it has routed. So now it will go to which microservice? Orders microservice. It's a different,
Correct.
entirely different team altogether. Okay. So
Mm-hmm.
now there is another layer of barrier inside. So this itself is the organization's layer, this entire thing or
Okay.
layer. Okay. And it is
Mm.
exposed via API gateway public domain, a public IP address. Okay. So now orders itself has its entire microservice altogether. This is a microservice. It's so which team is this one? For example, orders service. Okay, so that is how our
Mm.
product-based companies work. So you can ask which team I will be joining in. They will say you will be joining the orders service, orders team. So
Mm.
basically you will be part of this orders microservice. Okay, so like this, the
Mm. Mm.
product-based companies work. They entirely depend on. They have different teams, and the teams are based on microservice. Okay, so
So
now,
product-based companies, usually
mhm,
product-based companies will have
mhm,
uh,
different
microservices instead of having
right?
monoliths.
Yeah, exactly.
Mm.
So they have microservice, and you will be part of a single microservice. Okay, for example, you are a part of an
Okay.
order service. You can say someone is part of payment service. I am a part of my
Mm-hmm.
commercial service. So all those things. I am a part of marketplace service. Okay, so that's how
Mm-hmm.
microservice works. So slash orders API has come now onto the order service. So now consider this as a different microservice altogether. Okay, now very important things will come. Okay, so this was about the overview about before a particular microservice kicks in. Now we'll take a depth
Mm-hmm.
inside a particular microservice. Okay, so now an API server has come, an API has kicked in of your service. So at first of your microservice, there is another layer. This is similar to API gateway. Is its name is load balancer. You might have heard this term.
Yeah.
Okay, this is again
One question:
similar
this is
to
a
API
network
gateway.
load balancer, or
Mhm.
so this is a network load balancer, or like a virtual load balancer?
This
Network
is
load balancer, right?
this is your not a network load balancer. This is your API gateway load balancer, not the API gateway.
Is this a
HTTP
service? Like this is a service, you can
application
say.
level. Yeah, it's not a
It's an
service. It's
application
a
load balancer. Okay,
yeah,
okay, okay, okay.
application load balancer. Basically, it works on the level
Okay.
7, layer 7 of this one of network
Mm-hmm.
protocol. There are two load balancer, layer 7 and layer 4. Layer 4 that you're talking is a network load balancer, and the one we are
Mm-hmm.
talking is an application level load balancer. Okay, this works on the HTTPS and this works on the TCP. Generally, we talk about network load balancer whenever we deal with TCP raw data. Whenever internally their services are going to communicate, they generally talk to network load balancer. And whenever we are talking to external facing API, they generally happens on the layer 7 because that's the most secure
Okay.
one compared to layer 4. Okay. So
Mm.
generally we talk of the
Correct.
layer 7 load balancer. Okay. And very less time you will see we'll talk of the layer 4, which is a network load balancer. Application layer load balancer. It's basically a different server. It's again a server, but you will be
Okay.
provided everything in hand. You can create your own load balancer also, but everything will be provided this thing. I mean, out of the box, you will be getting all the features of the load balancer. So now, important thing over here is what does load? How do this API gateway routes this, and how do they communicate basically? So now this load balancer exposes us a public-facing API, not a public-facing API, and port. Okay, over here they exposes a port
Mm-hmm.
and the IP address of itself, which is only visible to API gateway. That means API gateway can talk to the port of this one, load balancer. Okay, so they exposes a port and then they routes the API. Okay, so and again, load balancer. So main job of load balancer is to route the traffic of the. Okay, I'll come to that more. So if you see load balancer, after that we have an application server. So these are application server, very important, most important components of the entire high level design. So what is application server? This is application server one, server two. Do you know what's an application server?
Is this where our main application resides?
Exactly. So that means your application, that the code that you have written, your business logic, and everything. That's what is deployed under these application server. So it can be of any type. For example, the most famous ones are Apache or no, not Apache. Sorry, your
Nginx.
servers are basic. No, Nginx is a kind of load balancer.
It's
So
a yeah.
basically, your a computer, entire computer, it will having x86. You will providing RAM and CPU and all those, right? It's like a computer that you are spawning, and inside that computer you are going to run the application, whatever application, Python or Java or any kind of application.
So
So
is it
onto
like an
this,
instance, like an EC2 instance we have? Like, is
exactly,
it
exactly,
into
not
that?
like it is the EC2 instance. Okay, this is an
Okay.
EC2 instance itself. Okay, so that's the correct word you have used. It's an EC2 instance itself.
Okay.
So now, if you see, there are how many servers at your screen right now? 4 servers,
4.
right? So now inside these 4 servers, what is running? Your code is running, whatever code you have written, right? Right. So
Correct.
now your traffic is being served by 4 servers, right?
Right.
So now what's the advantage? Why aren't we using a single server? Why are we using 4 servers? Whenever you get a huge traffic, you keep on spanning more and more servers. That's what is called horizontal scaling. You are spanning more and more servers to cater to more traffic. In scenarios of festive season, these can span up to more than 1K servers. So your EC2 instances can
Okay.
span up to 1K servers. So you can understand the scale at which the festive seasons, application servers are spawned, right?
Right.
So EC2 instances, and now you are deploying your code. So each and every instances will deploy the same application code that you are running. Okay, and now how do they auto scale? Whenever so they have certain thresholds over here. Thresholds as in CPU utilization or memory utilization goes beyond, let's say, 75%, they will spawn a new server itself, and then they will add it to the load balancer's backend. So let's talk more on the load balancer. So now load balancer's main duty is to route the load, right? So basically, so that the load does not gets distributed only on one, it is distributed evenly to all the servers. Any questions, do ask in between, okay?
Yeah.
Okay.
So I'm guessing.
Mhm. Tell me.
So load balancer is always, it's constantly checking the traffic, right? And it's constantly checking like how much
Mhm.
memory of CPU is being consumed by the
Mhm.
servers we are spawning, right?
No, load balancer duty does not depend on that. So load balancer duty is only to route the traffic. That's the most dumbest server
Okay.
you can think of. Okay, what's its duty is just to route the traffic. Okay, I have a traffic, I will simply route it to this one. I don't know how to route. There are various mechanisms via which load balancer routes the traffic. Now, what are those various algorithms? Okay, so they route the traffic on the basis of various algorithms. So first is round robin. So you might have heard of round robin, right?
Yes.
Any one by one sequentially it is routing. So first request came, it will route to S1, then sorry, S4, S3, then S2 and S1. Then again same sequential way it will follow that. Okay. Then there is a another algorithm which is called weighted round robin. Okay. So you will be able. Hmm. So how do we configure this one? You configure this at the load balancer itself. Whenever you are setting up the load balancer in AWS, you can set it up, weighted round robin, and which server will get how much weight. So for example, this server has got weight of 3, this has got a weight of 1, this has got the weight of 4, and this has got the weight of 2. So that means 2 requests over here, 4 requests over here, 3 requests simultaneously, kind of thing. Basically, more the number, more requests will be gone to that machine. will be going to that machine. Clear?
Mm-hmm.
So that's a different mechanism, algorithm. Then there is another uh, which is called on the basis of this one, stateless and stateful. So basically, a particular request will always go to that particular server. For example, any request which starts with VAV, right?
Okay.
Any kind of, for example, okay, we'll cover
Some
that part
identifier.
later. Yeah, some kind of identifier you can think of. So on that identifier, it is going to route. Okay, we'll touch upon that more in later part of the session.
Mm-hmm.
But for now, you can think this is the dumbest machine whose only responsibility is to share the load of this thing of the application server. Okay, so now the
Okay.
application servers is done. So now inside an application server, uh, just a minute. So let's deep inside into the application server. Okay, so this is your app server, right? So an application server, what all things does it have? It has its own memory. You might have seen memory is, for example, 75 GB. Application server has very less memory. You can make it a lot of
Mm-hmm.
memory, but we will talk why we keep a very less memory. It will have its RAM, for example, 15 GB or 16 GB. It will also have its core, 2 core, 5 core, 8 core, right? Just like your normal laptop, you can think of that. Okay. And then, so these
Mm-hmm.
are the specifications. And this is a single application server I'm talking of, a normal laptop. So now, application server is running your application code. And now this is having a RAM in itself, and then it can serve its own. Basically, you can store all the data related to your platform inside this one. But what is the problem if we store all the data in the application server? Hmm.
If we
Have you?
store all the data in the application server,
Mhm.
then the
For example,
application
your
server starts.
company data is stored
Mm.
in all the data you are storing in application server. What will happen? For example, you are storing all the data inside your
Okay.
computer. Very important
What does
critical
the
data,
data?
customer.
Okay, okay.
Mhm.
Customer related, yeah,
Everything you
like
are storing in
secret
your
data.
local computer.
Mm-hmm.
What will happen?
Then that runs into a security risk. Like
Hmm.
if my computer, let's say for example, goes down, right?
Hmm. Hmm.
In that case, or if my computer gets corrupted, in that case, all my data will
Hmm.
be lost. First of all,
Right. Very, very good point you
and
have
if
made.
it
So all
gets,
your data
if
will be lost.
yeah,
Right.
yeah.
For example, a very important customer's data is present on, let's say, on this one, and this data, this server got corrupted or something might have happened because every day servers makes and goes up and down, and then
Mm-hmm.
after restarting, the data is lost. After booting up, something might
Yeah.
have happened, right? So generally, what we do is we try to segregate the application logic or the business logic and the data logic as a different thing. Okay, so application logic is also known as the control plane layer. You might have heard a lot. And the data logic is also known as
Mm-hmm.
the data plane layer. So now, whenever someone will talks about ours is a data plane layer, ours is a control plane layer. Okay,
Mm-hmm.
you can think of control plane layer means application logic, business logic, application server, everything related to your Java code, Python code, whatever you are running. Right now
Mm-hmm.
comes an important part, which is data logic or data plane layer. It mostly deals with your persistent layer. This is also called persistent layer. What comes inside this one? Your DBs. Very important. All your
Mm-hmm.
database related, all the persistent data, you cannot lose these data at any cost because that's a huge loss, and it comes under reputation for companies. You can't lose data.
Mm-hmm.
Okay, we'll come to in further sessions. We'll discuss how companies make sure that they don't lose out of any data and all that data replication, sharding, and all that. We will discuss in
Mm-hmm.
later part. But for now, think of this is very important. So now your application layer is segregated from your data plane layer, right? So now, uh,
Okay.
so your request has come to application layer till now. Now, what it
Mm-hmm.
will do is it will perform some computation inside this one, and then it will fetch the data from the data plane layer.
Correct.
Okay. Now, this data plane layer in itself can be different. There are various scenarios of data plane layer. For example, only one database might not help because you are getting a lot of traffic. If one database is only used, then for that, what we do is we also uh, scale out the data plane layer as well. So what we do is we scale out this data plane layer the way we have scaled out the This is called horizontal scaling. Why it is called horizontal? What's the difference between horizontal and vertical?
Vertical is when we increase the size or increase the capacity of our existing database.
Right,
Right. So if it has 1 TB of space, then we go
right.
to 2
2
TB, 3
TB,
TB.
something like that. Okay, right.
Yeah.
Then why do we, if we have that thing, why do we go with horizontal scaling? What's the limitation of vertical scaling?
I think in case of vertical scaling, we can only like there's a limit to the amount of size we can. Maybe I'm wrong,
Right, right. Yes, you are
but
absolutely right. Yeah. So at a certain stage, after a certain stage, you can't expand beyond that limit. There's a limit to that. Okay, that is one reason.
Mhm.
Second reason is in a database there are limited connection pools that you can make. Okay, after that you cannot make more connections to
Okay.
that. The database will choke
Mhm.
in that case. So in that case, what we do is your data DB layer is also scaled horizontally. Okay, so this is
Mhm.
getting serving traffic. Okay, so now the entire architecture looks something like this. So now till now, your this diagram should be very much handy. So now in any system design interview, if you don't know anything, at least if you draw this diagram, the interviewer will know that you know at least something of high level design. Okay, so this is your so a normal this one a normal system design of any microservice looks like this. You have an API gateway, clients interacts with this one, then you comes under any of the microservice. So for example, I zoomed into a single microservice. It's a load balancer. First, they talks to DNS service. DNS gives us the route of the IP address. Over here, it gives us the IP address. Then load balancer. Then load balancer will route the traffic onto different application server. This is your application server 1, 2, and 3, 4. You can span as much as you want as per your scalability. And now after this one, to talk directly with DB, or there is another load balancer layer which divides the load of the DB layer. So this is your DB layer. Okay, there are various DB over here, DB1, DB2, there are DB3 and DB4. Okay, so this is again a load balancer. It just segregates this, basically distributes the load. Now you might ask why there are two load balancer. One is this one is this one, right?
Mhm.
So basically, DB will also be, I mean, fetching a load, right? For that, we use a database
Mhm.
a load balancer also, and a load balancer on front of. Basically, you can keep load balancer on in front of any network call. Okay, so that's the thing. Most of the time, we also skip the
Like,
this load
okay.
balancer. Yeah, yeah, you
Mhm.
were telling something.
So I it
Hmm.
seems like database might also be in a different server, no? A database will
Yes,
also have a
yes,
different server for
database
it.
itself will also be in a different server. Yes, that's a different
Mhm.
network call altogether. They are in different server. But, you mean, I mean, it's inside the organization itself, inside the same team can access it. Okay, so this one is your control plane layer. Very important term. Everyone will be talking whenever you join any product-based company. This will be your data plane layer. In some of the teams that I have worked on, they are different teams altogether inside a single microservice. Okay, so that's also
Mhm.
a thing. Okay, so
Can you
now we
repeat the
have
last?
this. So in some company, this control plane
Mhm.
team and data plane team, they can also be a different team. Generally, in most of
Okay.
the cases, they are in different same team because that's a huge microservice. So one team cannot manage.
Mhm.
So they are again segregated. For example, for us, because see,
Okay.
database layer itself is a very complex thing, and your
Mhm.
applications layer is a very complex thing. These two will be the different teams who will be working on database. Someone DB experts will work on DB related things,
Mhm.
right? So that's the thing. So it says my Zoom will end in 10 minutes. Upgrade or something something. Okay, so it will end. I will again send you the link. Okay, but before that, let me
Mhm.
see what I have covered about all this, and then. Uh, Most of the thing of the high level. So any questions till now? Let me check. Is there anything else? API gateway, DNS, API servers. Yeah. So till now we have discussed about this thing. Now, just a minute. Let me check. Oh, is everything? Syntax. Okay, so now let's move on to another thing. So again, one more thing over here is that
Mhm.
there is another layer known as caching layer. Okay, now caching, what's the meaning of caching? Caching is basically if you want to serve a request. So if you see there's a whole hell lot of paths that is being taken, right? This is hitting,
Mhm.
this is hitting, this is hitting, this is again hitting four layer. So
A
if
lot of
there's a
network
lot of
calls.
network calls, exactly. So for caching, there can we
Mhm.
can keep the so that it reduces the network call. We can keep caching at various levels. For example, before your API gate, at the API gateway layer, you can keep a cache layer, and then
Mhm.
at the load balancer layer you can keep a cache. At the application level layer, inside this one you can keep a cache. Before,
Mhm.
at the database layer you can keep a cache. There are various ways in which you can cache your data. Okay, what's the reason for caching? So that you can frequently serve the most recent one, and there are various mechanisms of caching. We are going to discuss this after some time. So I think I have covered most of the thing. There's one more concept that you need to understand is stateful versus stateless. Have you heard this term before?
Yes.
What is the meaning of? Can you
Yes. So
explain?
stateful is
Mm-hmm.
when our server
Mm-hmm.
remembers the state of the client,
Mm-hmm. Very good.
and stateless is when a
Mm.
server is not contained, like it doesn't have to remember. It
Right.
doesn't have to maintain a connection with the client.
Right. Very good. So that's how it is. So now, if you see, your application servers are this, right? And this is the load balancer. So now, if we route any request to any application server, what will happen? For example, your data is present in this one, right?
Hmm.
And you are making a call onto this one, this server, then it will again say that no data found. But that's not the case, right?
Hmm.
Your data is present at this one, right? So now your load balancer needs to be smart for that case, right? How
Hmm.
will it get smart? Via using this concept of stateful and stateless. Okay, so that is how we are going to see. I mean, there are various mechanisms. It does so. So one of those mechanism is called sharding, right? So sharding is
Hmm.
basically your data will go on to which application server. Your call will go on to which application server. That is decided on by various approaches. Like you can do a segregation various via various ways. For example, you can do a user ID based sharding. For example, your user ID is, let's say, 123. You hash it onto uh, uh, just a minute. I'm not sure if this will end. Let's see how many minutes will it end. Okay, mm, this is really disturbing. Okay, so yeah. So for example, your user ID is, for example, 123. Okay, and now you are going to hash it with the number of servers. The number of servers is 4. 123 on the, for example, sharding and technology mechanism. I'm using this as a shard. Okay, by
Hmm.
n, whatever is the user ID by n. What's this sum
Hmm.
turn to be? 3, right? So it will be routed to number 3.
Hmm.
So one is this mechanism you can follow. There are other ways also. So that's how you can make your system as stateful and stateless. Stateless is basically you don't decide on anything, just randomly pass all the application layer. Sorry, all the application server contains the similar data. Okay, it is not
Okay.
exactly
Okay.
you can say a data. It's a kind of thing you can say as a your related queries will be your related business logic will be present in this server itself. Okay, we'll see
Hmm.
why is it is so. We are telling about sharding. Okay, we'll come back to that one a later point of time. Okay,
Hmm.
so yeah, so for now, just think of that there is something called stateful and stateless, which we use it uh, for routing the request onto a particular API server. It can also be a database layer also. So now at the database layer, we mostly talk about sharding. Okay, we'll check onto that one also. So we have talked about API servers, horizontal DNS, and all that, right? So now. Uh, Deciding system mostly on these components. Okay. So now, whenever we talk about high level design, right, we generally decide the systems onto these components. Okay. That means whenever you are going to design a high level design, we are going to
Hmm.
design the system mostly onto these components. So first is you will check which database to use Okay, then the kind of caching mechanism you are going to use, then the scaling, how are you going to scale it, whether it's the horizontal scaling or vertical scaling, and then or you can do a delegation of the service. Okay, delegation is basically whether you need the data now or you can delegate it. Okay, all this will come to it. Okay, I'm just giving you an overview.
Mhm.
Okay, that means there's something called sync and async mechanism. This falls under sync async mechanism. That means you can delegate whatever is not needed. Then you also need to decide upon concurrency, whether uh, uh, normal concurrency in a multi-threaded
Mhm.
architecture. And then you
Mhm.
also need to decide upon communication, what kind of communication mechanism you are going to follow, whether it would be HTTP, gRPC, or UDP, TCP, all that, right? So mostly
Mhm.
we talk about these components whenever we are going to design a high-level design. Okay, what kind of database you are going to use, what is the caching, is there any caching that we can do at any level, what's the scaling mechanism we are going to follow, whether we can delegate anything, whether what's the concurrency mechanism that we are going to follow, and what's the communication
Mhm.
strategy that is going to be followed. Okay, okay.
Okay.
I think for today's session, this was enough. We can also con discuss about uh, some caching. Okay, just a
Okay.
minute. So let's discuss about caching today. So now important thing, this part I'm talking of. Okay, now caching. Now if you see, where do caches sit in? Can you think of places where caches can fit in? I have told you,
Yeah. So
right?
one
Yeah, yeah.
is,
Tell
yeah.
me.
So one place I can think of is
Mm-hmm.
at the uh, view level, like when designing a view. Like so when we get a network request for
Mm-hmm.
a resource,
Mm-hmm.
right? So in those places where we have to get the data from database, right?
Mm-hmm.
In those places, so before making a database request,
Mm-hmm.
we can use the caching mechanism.
Yes, that is one part. Absolutely
Yes,
correct.
another one is at the
Mm-hmm.
load balancer level,
Right. Then,
application level. There's an
right.
application level.
Application server layer. Talk about in which context you are talking. Talk about everything. Okay. So be specific, whatever you are saying. Yeah, tell me.
Mhm.
I'm just drawing the various levels of a high level design. Okay.
Mhm. Yeah, so we can for like do it at the API gateway level.
Mm-hmm.
We can do it at load balancing level, and then we can do it at application control layer level,
Control plane
and
layer.
then
Yes.
control plane layer, yes, and
Mm-hmm.
then data plane layer level.
This is database load balancer. Okay. And this is
Mm.
your database. Yeah, you are correct.